Hi, my name is Lingo. Today I'm going to be talking about construction preparation and practice. A lot of this goes along with the previous lecture that was given by Nick as far as quality control. So we'll see how those are tied together. So as an overview, we're going to talk about some differences in the different types of construction and how masonry is different from other types. We're going to talk about why construction preparation and practice matters, what it affects, and how it's controlled. So if you look at these other methods, we have steel construction, concrete construction, and then masonry construction. Masonry is a lot different than the others. Steel has a lot of fabrication in the factory under controlled circumstances. And so the steel is fabricated in the shop, sent out to the job, and erected. There is little inspection that has to be done while construction is going on, because a lot of it can be inspected just by looking at the bolts, make sure they're tight after it's already constructed. Concrete's a little different, but it's still different from masonry. The reinforcement is usually laid and then inspected, and then the concrete's poured. The concrete itself is tested separately. And so throughout the construction progress of concrete, there's usually only a couple of inspections. One once you clean the pits, then another while you place the rebar, and the rebar is inspected before you pour the concrete around it. Masonry is a continuous process. Once one block is laid, you can't go back and look inside of it. But at the same time, unless there's a constant supervision, you're not able to see as the work progresses. So we're going to look at how that's affected. So, kind of summary of those. Steel is inspected in an as-built condition. Concrete is inspected before the concrete is poured. And then masonry needs to be inspected periodically to ensure reinforcement and grounding is adequate, but it can't be always inspected continuously because it's side of the job. Okay, and so why does this matter? Poor construction can lead to poor durability of structures. That results in safety concerns for occupants and also strength concerns for the material not being able to pull up to the strength. So, quality control. Some of the things that are monitored in masonry construction, as far as pre-construction, would be your foundations. Okay, so foundations have tolerances for alignments, elevations, and thicknesses. And so you can see at these points, if a foundation is out of alignment, it will have to be corrected. There's a 1/4 inch tolerance. If its elevation difference from one end to the other is greater than 1/2 inch, you end up having to put a mortar base down to level it. And so this explains the steps that are taken after if you have an uneven foundation. So if you're varying less than 1/2 inch between the ends, then mortar thickness can vary from 1/4 inch to 3/4 of an inch down from one end to the other. So that can make up the difference. If you're outside of that 1/2 inch tolerance, then you have to get the concrete leveling topper on top of your foundation in order to meet that 1/2 inch criteria. Some of the effects of an uneven foundation would be cracking. So if you can imagine bricks trying to slope too much of an angle or sloping at a peak, it's going to create high stress points, high stress concentrations in those areas, which will end up cracking the brick. Okay, and so now we're going to talk about some of the construction practices for weather conditions. Okay, first one is going to be cold weather. Cold weather is described to be less than 40 degrees Fahrenheit, and that's based on the wind chill temperature, not the actual temperature around the site. And so some problems that happen when cold water, or when there's cold weather, would be poor absorption, bond reduction, and the cold blocks drawing heat from the mortar and not letting it cure. And so for those who know about the curing process of concrete, you know that there's a heat gradient that has to form, and if that heat's not there, then the mortar will stop curing, and so that would result in the loss of strength. The bonding actually occurs because the water in the mortar and grout will not be able to be hydrated doesn't occur. Okay. So some solutions for cold weather. You have two options really. You can either enclose the site to get between 50 and 60 degrees. For those, if you think most structures, masonry is usually outside of the building, that'd be very difficult to do. So the second option would be to heat and mortar. And so there's a couple options to do that. You can either heat sand, and there's a limit. It can't be scorched, which means hotter than what you can touch with your hand. But generally, you can see over here, that's the sand being heated. The other option would be to heat the water. And so the water has a limit of 150 to 180 degrees. These limits are imposed so that you don't get flash setting. And what flash setting is whenever the mix actually hydrates too fast, and the grout and water will actually start to set before within a matter of minutes after you mix it. So, okay. And like I said, the reason is, or the other option would be to put admixtures into the concrete that would provide it to gain strength faster before the freezing occurs. So if you had a really cold condition, you could use these methods to heat the mortar and then use an admixture to make it set faster, so it doesn't have to set all as long. So, some other solutions. So for dry frozen blocks, they must be greater than 20 degrees Fahrenheit and free from ice. The ice on the bricks would prohibit the water from penetrating into the bricks, and that would be that bond reduction we were talking about. And then any wet bricks can't be used, and because of that poor absorption rate. After you have laid blocks, you can see over here they have a structure. You can enclose them so they're protected for 24 hours against rain, snow, and freezing. And then you can use heat lamps or blankets to keep that above 32 degrees temperature. Also, if the wind is greater than 15 miles an hour, you're required to put a wind block on the structure. And sometimes that's done through scaffolding along the side of the building with the glazing on the outside of the scaffolding. So the scaffolding will take the load instead of the brick, or it's done by shields placed on the ground if it's a low-lying structure. Okay. For hot weather, which is temperatures above 100 degrees or temperatures above 90 degrees with a wind greater than 8 miles per hour, you have certain parameters that you have to watch out for too. And so, some of the problems with that is it causes evaporation if you're mixing water inside the grout, and then that will lead to early initial set or loss of strength due to not being enough water for hydration. So, some of the solutions is to cool the water, mixing water before you put it in. So you can usually see people with ice buckets around the water, but you can't put ice into the mix. And so usually it'll have a tub that has ice in it with the mortar sitting inside of it to cool it down. So you must maintain a water temperature less than 120 degrees, and once the masonry is laid, you have to fog spray it 3 times a day for at least 3 days if the temperature is that high. When it's greater than 115 miles an hour or 105 with an 8 mile an hour wind, then you must use equipment to shade the brick from direct sunlight. Okay. Now we'll talk about wet weather. So, wet weather construction is unpermissible unless you're sheltering the actual construction blocks. And so they do not get wet because if the bricks are wet, then that affects their absorption rate because they've already absorbed water, heated up with warm water in the mix, and once a product is greater than 24 hours old, so if you go out and lay a block, let's sit there for 24 hours and then the rainstorm comes, it actually helps with the hydration process. So it's permissible to uncover those units after that in order to help hydration. And the last weather condition we're going to talk about is windy weather. And so some of these others have had the wind factored into them. This is just for if you were normal temperature with high winds, which is likely here in Oklahoma. One of the risks is premature drying. And so as you see in this picture over here, you see these little cracks. those are shrinkage cracks from the mortar drying too quickly. And so that's the reasoning for the wind being a problem. Also, if you have a structure that's decently high structure, the wind can cause collapse because it doesn't have flexural strength at that point. And moist gearing and wind screens are usually used to prevent these. Okay. Here is wind bracing. And so wind bracing is used for those tall structures that you are susceptible to blowing over in the wind. In your manual, it gives the tables that tell you different wind speeds, how thick and thickness of the walls, how often you have to space your bracing, and what type of bracing you have to have. Often this is the bracing that's desired. Compared to this one down here, you can see that it doesn't have this little kick stand right here. The problem with those is that they would be able to move with the wall instead of creating a moment against the wall. So that's an important detail when you're providing wind bracing details. Okay. Some of the other construction techniques that we have would be flashing. Flashing is used to prevent moisture buildup behind the wall, in between the wall and the structural element of the building. So you usually put flashing around joints, around windows and edges. And so here's an example of a joint at the bottom of the wall flashing at the bottom of the wall. Flashing takes the condensated water that could condensate back here. Once it comes out, it pushes it out. All flashing needs metal drip edges so that it prevents corrosion of the actual flashing in the wall. And then we're going to talk about joints. And so there's two different kinds of joints: control joints and expansion joints. Control joints are concrete masonry, and they are used to prevent cracking from shrinkage. Expansion joints are in clay masonry, and those are used to prevent cracking from thermal expansion. So typically those are spaced at 30 feet intervals, vertically and horizontally. And so if you have expansion and shrinkage this way as well as side to side. So now we're going to talk about some different joint types. And so these are different joints that do different things. And so you can specify joints based off of what your performance is want. Concave joints and V joints are typically done because whenever you lay that the grout in there, or the mortar in there, and then you stack the bricks, you come back out with the trowel, and what you do is you push this in, so that creates a very dense surface right here on the edge. That prevents water absorption into your wall. Flush joints are often used for areas where you're going to apply ephes or a stucco to the side of your masonry. That provides a flush area of contact for those substances to stick to. Rape joints are ones that are set back into the brick. They're usually not very good for water absorption purposes, but they are sometimes specified by architects because of the way they look at the masonry. And you have extruded joints. Those are usually in interior walls. Bedded joints in the same way. Strut joints are very uncommon. I did not find why you use strut joint, but those are weather joints are often used because if water comes down, they push the water out instead of letting it saturate into the brick. Alright, so now we're going to look at the importance of why we have these quality control and construction inspection things. And so, whenever you have these construction practices, you do them, it creates good structures that can stand up. It also provides a product that is safe for the environment. So, this is kind of how you get good quality structures. This goes in a lot of what Nick said already. But good communication between the designer and builder. If the designer specifies something one way, and the builder doesn't understand those details, then This is the same chart that Nick just showed. It's a quality, or the minimum inspection for Class C. And so he kind of already talked about the different classes that are over here, but I just want to show this chart because as you see, like for Class C, and this is the most strict class, that there's a lot of things that aren't even continuously inspected. And if you think on a large job site, even if they're continuously inspected, you're not going to have someone inspecting each person all the time. And so there's a lot of room for error to happen if inspection and training isn't implemented into